All right, so this is section 1.5, complex numbers. You guys are going to have a test on Tuesday over 1.1 through 1.5. I will go over the quizzes probably on Monday because I still have people that have to take it. Guys, if I ask you to come to a Zoom makeup, I need you to show up at that Zoom makeup time because I have to do a different assessment every time, so it's just kind of, it makes it tough to go over things if I have to keep waiting for people to take their makeup. So when you're doing your web assign, guys, it is very important that you pay attention to this. You have to have your complex number written in what they call standard form. The real part first, the imaginary part second. Meaning, if I have like 6 plus 3i, this is the real part, and this is the imaginary part. How can you tell the difference between the real part and the imaginary part?
It has the I next to it.
Yeah, the imaginary part has the I next to it. Another thing you need to remember is I squared equals -1. That's super, super, super important to remember. We'll talk about that more. But this is called a complex number. It's made up of two different parts, the real part and the imaginary part. So make sure you guys are understanding that the real part has to go first, the imaginary part second. Important. Just some examples of complex numbers. When you have a real part versus an imaginary part, the real part here is 3, the imaginary part is the 4i. Real part is 1/2, the imaginary part is the -2/3. When you have just an I, there is a real part, it just happens to be 0, it's out in front. When you have a constant, just -7, there is an imaginary part, it just happens to be in the back. So just make sure you guys are aware of the different pieces of a real part versus an imaginary. All right, so let's do some problems. Let's do A together here. I have 3 plus 5i plus 4 minus 2i, okay? Really important thing you need to remember, guys, this is combining like terms. That's it. This is like saying 3 plus 5x plus 4 minus 2x. I have a plus sign in the middle. First thing you need to do is check out the middle. So real goes with real. 3 plus 4 is how much? 3 plus 4. 7, thank you. And then 5i minus 2i is what?
3i.
Plus 3i. My real part is the 7. The imaginary part is the 3. Anybody have questions about that? All right,
No.
Let's look at B. B is 3 plus 5i minus 4 minus 2i. Is this the exact same problem?
No.
No, how is it different?
The minus sign in the middle.
There's a minus sign in the middle. When there is a minus sign in the middle, what do you have to do with that minus before you can combine like terms?
Distribute.
You have to distribute it. If you guys do not distribute it, your answer will be wrong. Make sure you pay attention to that. Distribute that negative. I have -4, and then a negative and a negative gives me a positive. So now deal with your real parts. 3 minus 4 is what? -1. And what's 5i plus 2i?
7i.
7i. Again, real part, imaginary. Questions? Okay, let's look at the third one. Same numbers, right? Yep. Okay, so C is 3 plus 5i and 4 minus 2i. What am I doing in this example?
Multiplying.
We're multiplying, so we're going to FOIL. 3 times 4 is 12. 3 times -2i gives me -6i. 5i times 4 gives me positive 20i. And guys, 5i times -2i gives me -10i squared. As soon as you see I squared equals -1. What I need you guys to do is cross off the I squared, change the sign in front of the number. Because if I have -10 I squared, that's the same as saying -10 times -1, which would give me positive 10. So anytime you have I times I, I'm always going to say, cross off the I squared, change the sign in front of it. Cross off the I squared, change the sign in front of it. You should never have an I squared in your answer because I squared equals -1. So now I deal with my real parts. 12 plus 10 gives me 22, right? And then -6i and a +20 gives me what? +14i. There's my real part. That's my imaginary. Questions? Oh my gosh, now we get to dividing. And when we get to dividing, we think, this is so hard, I can't do it. It's just crazy. No, it's not, right? Complex conjugate. If I said to you, let's just do some examples here. If I said to you, okay, I have -3 plus 4i, 7 minus 5i. And I said to you guys, what's the complex conjugate of these two? Complex conjugate, write this down. You change the sign in the middle when written in A plus BI form. If I said to you, what is the complex conjugate of -3 plus 4i, you guys would tell me it's -3 minus 4i. You change the sign in the middle, just the one in the middle, not the one in the front. Just the one in the middle when it's written in standard form. So I have 7 minus 5i. What's the complex conjugate of 7 minus 5i?
7 plus 5i.
7 plus 5i, good. If I had -4i minus 6, can I do the complex conjugate yet? What do I have to do first?
Put it in standard form.
I got to rewrite it in standard form, so it'd be -6 minus 4i. Now the complex conjugate of -6 minus 4i is -6 plus 4i. It's got to be written in A plus BI form, so you got to switch it first. But you'll see why that's important in just a second.
-7.
All right, if I'm dividing, let's look at A. All right, I have 3 plus 5i over 1 minus 2i. Okay, there is a major rule that you guys have to write down and remember. No I in denominator. You know how we can't have a radical in the denominator? We multiply top and bottom, we rationalize to get that radical out. We have to do the same thing when you're talking about division. I have an I in the denominator, so the first thing I do is say, uh-oh, I need to multiply by the complex conjugate, and you'll see why in a second. First of all, is my denominator written in standard form? The real part and then the imaginary part?
Yes.
Yes. So what is the complex conjugate of 1 minus 2i?
1 plus 2i.
1 plus 2i. Guys, in any fraction, what you do to the bottom, you do where?
The top.
To the top. Now this becomes one big multiplication problem. That's it. Let's deal with the denominator first. What is 1 times 1? 1. What is 1 times 2i?
2i.
Okay, what's negative 2i times 1?
-2i.
And then what is negative 2i and a positive 2i?
-4i.
4i what?
Squared.
Yep, as soon as you see I squared, what I tell you to do, cross it off and do what? Change the sign in the front. Okay, so I'm still going to stick with the denominator here. Work with your reals. What's 1 plus 4?
5.
5. What happens with a positive 2i and a negative 2i?
They cancel out.
They cancel out. The reason we multiply by the complex conjugate is because when you do that, the i's will cancel out. Because you're not allowed to have an I where?
In the denominator.
In the denominator. So every time you do a division problem, you should end up with just one constant whole number in your denominator. If you have i's, you did something wrong. You've got to multiply. This first step, you have to multiply by the complex conjugate. And the reason we do that is to get the I out of the denominator. So now we just work with the numerator in our multiplication. Guys, FOIL it. 3 times 1 is 3. 3 times 2i plus 6i. What's 5i times 1? 5i. And what's 5i times 2i? What's 5i times 2i?
10i.
Thank you. Plus 10i squared. Uh-oh, as soon as I see I squared, what do? Cross it off, change the sign in the front. Every single time you'll do that, and what will happen is the first number and the last number become real, and then you can combine them. So it's 3 minus 10.
Wait, what?
Wait, what? With what?
You should just sign up the number.
No, it's not that you're just making it non-imaginary, but when I have plus 10i squared, okay? The value of I squared, MJ, we said at the beginning, was -1. So this is saying plus 10, I squared equals -1. What's a positive 10 times a -1? -10. So what you're doing is you're multiplying. When you have I squared, all you're doing is multiplying the number that is with the I squared by -1. So in a sense, you're just crossing out the I squared and changing the sign, because when you multiply something by -1, it changes the sign of it. Does that make sense? Okay, I'll do another one then. So let's combine here. What's 3 and -10? 3, anybody. 3 plus or 3 minus 10 is what?
-7.
-7. And then what's 6i plus 5i? Gives me how many i's?
11.
11i. And then there's your answer. If we do letter B, all right, let's do letter B right here. It's 7 plus 3i over 4i. Well, what's the opposite, guys, of positive 4i? So I'm going to multiply the top and the bottom by -4i. So MJ, watch this. Ready? Let's do the bottom. What is 4 times 4?
16.
16. And then what's I times I?
I squared.
I squared. But what do you know the value of I squared really is? It's not, I squared is equal to a real number, which is what?
I don't know. It's 2, 1.
Right here. Remember we said I squared equals -1.
Okay.
The value of I squared, you've got to commit that to memory. Value of I squared is -1. So when I see I squared, I cross it out and I'm saying, okay, this really is -1. So what is -1 times 16?
-16.
-16. So that's why I say you can just cross out the I and change the sign in the middle or in front of it, wherever it happens to be.
But that's only if you have I squared, right?
Yeah, other than that, you just combine the i's. Like here, this is going to go, okay, so what's 7 times -4i? What's 7 times -4? -28. Anybody? -28, and then there's an I. It's the same thing as if it were an X. If I said -4x times 7, you tell me it's -28x. Same exact thing. Now if I say 3 times 3i times -4i, well, 3 times -4 is -12, right?
I squared.
I squared. Now MJ, the value of I squared is what? -1. So if I had this problem, -12 times -1, you would tell me it's +12, right? So that's why I say when you say I squared, you can just cross it off and change the sign that's in front of the number. Now, if I was going to write my answer, what would the numerator look like? Has to be in standard form.
12 minus 28i.
12, because it's positive, minus 28i. We always need to look to simplify, guys. Say it again, MJ. It has to be written in standard form, a plus bi. The real part has to come first.
the homework, whenever there was an I in a
If they ask for the real solutions, then if you get an imaginary, you'd say no real solution. But if it's just telling you to solve, and it doesn't say anything about it has to be real or imaginary or anything like that, then you would just give the imaginary answer if there's imaginaries in it.
Okay.
But look at this, guys. What do you notice about 12, 28, and 16?
They're all divisible by 2.
They're all divisible by something, right? So look, this is a fraction. I can rewrite this as 12 over negative 16. And then 28i over 16, right? Can I do that?
Yeah.
Can I split up a fraction? I think that's a good idea for you guys to do at the end to just see if anything simplifies. Because 2 can go into here, right? 6 over 8. 4 goes into here. This would become what? Negative 3/4. What goes into 28 and 16? 4? Yes or no? Guys, we're simplifying a fraction. Okay. So a negative divided by negative is a plus. 28 divided by 4 is 7. 16 divided by 4 is 4. So you can keep your answer like this. You can keep your answer just like this. Or since the denominator is the same, you can write it over one denominator. Either or. I'm not sure how WebAssign's going to want it. I don't know if they're going to ask a certain way. I don't care personally. Either way you write it on a test, it doesn't matter to me, but you need to always, 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 always simplify. If you leave it without simplifying, you guys are going to get points off. All right, let's I'm not going to worry about this right this second. Okay, we're going to talk about our quadratic formula. Guys, from now on in math, you need to know the quadratic formula. Now, what MJ just asked about, if the discriminant, remember this, if the discriminant is less than 0, meaning it's negative, if you have a negative under the radical, all right, exactly what MJ just said, it's no real solution, okay? But complex numbers are solutions. They're just imaginary. So if the question asks you for all of the solutions, then you can give the real ones or the imaginary. If they ask you for all the real ones, then they just want the real stuff. So if I have these two questions, let's look at this. Let's look at letter A. All right, I have x squared plus 9 equals 0. Whenever we have a quadratic, we always try and factor first. Always. Some of you would tell me, oh, this is x plus 3 and x minus 3. Is that true? Whoops, I don't know why I wrote 9. Is this x plus 3 and x minus 3? No, it's not the difference of perfect squares. If I FOILed this out, I'd get x squared minus 9. This is x squared plus 9. What I want you guys to see, try and solve this. Can you solve this to get x all by itself? What would you do? How would I get x all by itself?
Subtract 9.
Okay, if I subtract 9 from both sides, I get x squared equals negative 9. Now what?
Root both sides.
Okay, take the square root. When I physically put the square root on a number, what goes in front of my answer?
Plus or minus?
Plus or minus. Now, the square root of 9 is 3. But what is the square root of negative 1?
1.
Nope. The square root of negative 1. We talked about this the first slide.
I.
Square root of negative 1 equals I. So this would be 3i. Plus or minus 3i. It's not a real solution. It's imaginary. Like if I were to graph this, all right, plus 9, that means it moves up 9. Let's pretend this is 9. It's a parabola. That's positive, and it's going upwards. Real solutions are where does the graph cross the x-axis? Does this thing cross the x-axis?
No.
No. So it doesn't have any real solutions. It doesn't cross the x-axis. It has solutions, they're just not real. So do you see how, MJ, this says solve each equation. If it just says solve, tell me what the answer is. If it says solve to find the real solutions, then your answer here would be no real solution because they're imaginary. Does that make a little bit of sense?
Yeah.
Okay, you can tell me no, that's okay. I can try and re-explain it. All right, I have a quadratic and they're telling me to solve it. Solve means try and factor it, set equal to 0. Are there factors of 5, guys, that'll multiply to give me 5, but add to give me 4?
Yes.
What are they?
No. Wait, yes. No.
I could get 5 minus 1 would give me 4, right? But if I multiplied 5 and a negative 1, I'd get negative 5, not positive. So then we're like, oh man, what do we have to use? What's this called?
Quadratic.
The quadratic formula. From now on in math classes, until you don't take any more in college, you need to know the quadratic formula. So the first thing I'm going to do is say, okay, my a is the number in front of x squared, so a is 1. B is the number in front of x, so b is 4. And c is the constant, which is 5. And now we're just going to solve. I'm going to write down my quadratic formula so I can make sure I plug everything in right. B squared minus 4ac all over 2 times a. So negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 5 all over 2 times 1. This is where you check. This is where you stop and say, do I have my signs right? Did I plug all the numbers in correctly? Because now it's just a matter of simplifying. That's it. But this is a big step to make sure, especially if you have any negatives, that you have all of your numbers written correctly. Do I? Does it appear that I do? Okay, good talk. So we're going to say negative 4 plus or minus. Everybody with me? What is 4 squared?
16.
16 minus, what's 4 times 1 times 5?
20.
20. All over 2 times 1 is 2. Okay, keep simplifying. Negative 4 plus or minus. What is 16 minus 20?
Negative 4.
Negative 4 over 2. What do you notice is happening underneath the square root?
It's negative.
It's negative. So is that a problem?
Yeah.
Okay. You don't have to do this step that I'm writing right here. I'm just showing you. Because when you simplify this, guys, what is the square root of 4?
2.
It's 2. What's the square root of negative 1?
I.
That's where our I comes from in our answer. If there's a negative underneath the radical, you should have an I in your answer. I separate it like that so you guys can see, oh, I see that negative 1, it has to be an I. So now we just keep simplifying. I have negative 4 plus or minus 2I over 2. And we're not done. We're really close to done, but if you guys notice, 2 can go into 4 and 2. So I'm going to rewrite it as 2 separate fractions just so I can see my simplifying better. All I did was just separate the first term over the second term. It's under the same denominator. So I can say, okay, well, negative 4 divided by 2 is negative 2, plus or minus 2 divided by 2 is 1, so it's just I. So there you have your answer. I think on WebAssign, it tells you to enter your answers separated by commas. So they want negative 2 plus I, comma, negative 2 minus I believe. Miss Meadows, will take it either way. WebAssign, I think, wants it this way on the bottom. I think.